thought we'll maybe go for coffee. All right, yeah. So yeah, I started the stream again. So we kind of discussed about what this means, and one natural maybe idea is just to say, let's create a big grid graph and with some number of edges, and another star graph with fewer number of edges. Dump all the edges in a big bag and sample edges from that bag at random, uniformly at random, right? This is one simple approach. Then we will just be able to write to files with a given number of edges at each batch. Okay. The other idea is maybe have a out neighborhood specific focus, and let's just do this. So a 50 by 50 grid graph has 4,900 edges, and a 101 star graph has 100 edges. So now okay, union, union, we're going to try to union the two. Um, so I don't know if this works nicely. So seems to work. Okay, so I have my graph I want. Okay, so what is 100 divided by 5,000? Scala is really clever. Okay, 0.02. It's not quite what we want, but okay. So we can try to do this. It's close to the mixture we were after, right? We wanted 0.01. Or we could go there, but I guess 100 divided by 10,000. Okay, we can do this. So, but the problem is, it's going to be rough, right? Because 10,000, yeah. So this is a math class mostly, so we can just change the problem. This is the only problem with industry jobs, right? You can't change the problem. Okay, so let's just stick to this. So it's 4,900, and we want to do a mixture. Okay. So now what?
The star graph, everything will be pointing to the 0 vertex.
Yeah.
So it's not.
Yeah, it's made up, man. I mean, yeah, I'm saying 0. Yeah, it's a star graph. Just like the location family, right? You're making it up.
Yeah.
But for now, right, we can do really beautiful things soon, right? We can simulate from empirical graphs, right?
Okay.
So what's an empirical graph? You just have a shitload of data, and you just find the empirical in and out degrees, just empirical edges, and you can literally simulate from that later if you want.
Right.
But just to get us going, debugging, whatever. And so it's conceptual debugging going on. What do we mean by a mixture of graphs? So anyway, so why don't I kind of leave it to you guys here? You can do something, and maybe we can share our solutions later, right? Because I think tonight there is a Git session. So I want you guys to start contributing, making pull requests and things like this. So there is some public signature of your activity. Yeah. What?
Pull request or not?
What?
pull request or what?
Well, okay, this is just a silly example, but the idea is that your course projects are going to be done in these notebooks, and you will have your own Git repo, whoever you are. And then you could, for example, make a pull request to a particular directory of this book we're writing, right? Because I will maintain the repository, or Don, I don't know, Tilo maybe. So because we're editing this thing, right? So you can make a pull request, and we can say, whatever. So you're officially pushing.
Some content.
Yeah. So I will, So this way we kind of start doing things. So we don't have to be in the same room in the future, right? That's how these Apache projects are basically happening. People all over the world. Okay, so let's maybe take a quick coffee break. But before that, let me tell you the plan for the rest of today. So what we did, so if you missed, please watch the structured streaming stuff from yesterday. There's a lot of concepts here. I will let you guys maybe go through this on your own. This is like exercise basically to come, essentially it's just a Databricks notebook I pulled out. It gives you JSON files instead of just text files we were playing with yesterday, and it concretizes some more ideas. So we may not go through this to save time. What I then want to do is, this is exactly the same mixture of two normals. So we're going to simulate that little bivariate Gaussian example. But what we want to do now is get a feel for sketching. Okay, this is a very important concept in big data. And we'll watch like a 10-minute video, walk through this blog post quickly. And then I'll jump into what I think is one of the best libraries right now for this thing called T-Digest. And so we will kind of simulate a situation where we're trying to detect anomalies, these weird blips from the Gaussian at location 10. We'll try and detect that using T-Digests. And then I'll set the stage for the real problem, which is streaming T-Digest. And I went to bed around midnight. Tired. I haven't gotten to the bottom of how to implement our own streaming T-Digest properly. In fact, I'm getting some help from data scientists at Combiont right now. So hopefully next week I'll roll this out for you guys. Okay, so that's the plan for after break.